爱的观众朋友们，大家好，欢迎来到观察者网观学院直播厅心智对话节目。我是对话主持人、观察者网总编办 Kelly 刘倩黎。首先，请允许我简单介绍一下，观察者网是互联网新媒体，我们在 Web 2.0时代应运而生。我们用多元的方式向全球和全网的用户提供观点和资讯。我们是媒体，是智库，也是社交媒体平台。每天有海量的用户和我们互动，也有很多专家、作者和学者为我们提供宝贵洞见。那您现在观看的心智对话呢，是围绕心智生产力打造的一款科创类谈话节目。那我们今天一起将走到光刻之巅，从前排视角来看一看阿斯麦尔40年发展史，让我们一起来拆解一下全球的芯片博弈。今天有幸请到荷兰资深光刻行业观察者、科技记者、聚焦阿斯麦尔之道作者马克·海辛克先生和中国科学院上海光学精密机械研究所超强激光科学与技术全国重点实验室副主任、原阿斯麦尔研究部研发科学家、研究部量检测光源技术负责人林楠博士。那我们接下来对话呢，将用英文进行。Ladies and gentlemen, good afternoon. I'm Kelly from Guancha. It is to my greatest privilege to have two gentlemen to join us for today's tech show, Sinzhi Dialogue. Well, Guancha is a leading digital media, and we were born in 2012 and headquartered in Shanghai, China, with a dedicated team of 200 members and hundreds of affiliated contributors worldwide. We consistently provide quality info and insights on current affairs on both China and world affairs, covering politics, technology, business, and culture. Across a host of social media platforms, we have over 120 million readers and subscribers. As a privately owned media outlet in China, we strongly believe in the importance of letting different opinions be heard on the global stage and to strive to provide a platform for voices that are neglected by international mainstream media. Well, our topic today is very hardcore. If we believe chip is crown of all industries, then we're going to talk about is the jewel in that crown and craftsmen who designed the jewel. There's no denial that chip power our today's modern society, from data centers to smartphones, from coffee machines to cars. And to make every single advanced processor chip, and we need the most advanced equipments. We know Asml, as a Dutch company, has a total monopoly on the fabrication of that machine, and 90% of the world's most advanced chips were made with Asml's machines. And the two gentlemen who join us today are the best positioned to tell the stories of Asml. Mr. Mark Hijek, a Dutch journalist and tech reporter, and he went down a 3-year journey with unparalleled access to Asml and finished with a fabulous book, Focus, The Asml's Way Inside the Power Struggle over the Most Complex Machine on Earth. Welcome.
Thank you.
Thank you
for hosting us. Excellent.
Thank you. And next gentleman, Dr. Lin Nan, Vice Director of State Key Laboratory of Ultra-Intense Laser Science and Technology at Shanghai Institute of Optics and Fine Mechanics, Chinese Academy of Sciences. He previously served as an R&D scientist and competence owner for metrology light source at ASML Research. Welcome, Dr. Lin.
Thank you.
Yeah.
各位观察者网的朋友们，大家好。
Well, it's an interesting talk. I mean, I'm a student today. I'm also an observer, and I'm the most powerful lady on site today because I'm going to, shoot two questions. So first, I'm going to ask you, Mark, as a reporter and a columnist, and you have been covering geopolitics, technology, trade wars for more than 15 years. And so with this 3 years of experience diving into the inside stories of ASML, and how do you find the experience different from your previous writings?
Well, for me it was quite adventurous, I must say, because I was used to writing about ASML, well, talking about its financial results or diving into technology. But during the time I spent behind the scenes and talking to the leadership, I also got to know the people and the special characters that are working at ASML. And it was for me exciting to be able to get as many interviews and get to travel around the world to see all of their companies' divisions and research labs to get these crazy stories out. And I had the luck and the opportunity to put it in this book. So it's a completely different experience from my work as a newspaper writer for the Dutch newspaper called NRC. but it really added on the foundation of the relationship that was already there with ASML. And the funny thing is, to gain trust of an engineer, I think it's very important that you really are interested in their technology, even though it's complex. And well, as Dr. Lin can say, it's very complex sometimes, but that way you can really win the heart and hear the other stories behind the technology. Because in the end, technology is made by man, and I think this book really tells that story.
So have you heard from them about the feedback of your book? I mean, ASML's people.
Well, I think the best feedback I got was from the former CTO, Martin van der Brink. He's like the protagonist in the story. He was employee number 0. He started out during the Philips days, which was the mother company of ASML's technology. And when he started a window of time of 4 decades, and the last couple of decades he was basically the CTO who decided what the roadmap would be and what the technology would be. And he was like the Steve Jobs of lithography, so to speak. And he's really a character, challenging character. And also challenging during our interviews, but it was really inspiring. And the most inspiring actually was when the first Dutch edition was out. He sent me an email 5,000 words long with things I got completely wrong, half wrong, what could be improved, and what he liked about it. So he was diving into this book 1 weekend long and came back with so much valuable feedback that I, of course, put it in the book. And for me, that was a huge compliment because, well, this brilliant guy, decided to spend so much time with me and so much time in improving the end result. And because to him, ASML was, well, a bit like a baby. So he also was very touched when he had to leave because his pension age was there. And so that was great feedback. And also, well, I think yesterday somebody sent me an email and saying that people at ASML recognize themselves in this book. And I think that's because they gave me freedom to also search other sources outside of the company. So I talked to suppliers, customers, politicians, diplomats, people who are not too fond of ASML, so I could provide a more objective image. It's more like a mirror. And I think ASML is one of these rare companies that really appreciates the honest, objective vision on their company. And I think that's quite rare for a public company, at least.
Yes, and thank you for bringing us to the front seats to look at this giant company. 林博，我想问一下您，就是这么硬核的一个光刻机是怎么样，就是人生是怎么样把您跟光刻机链接在一起？您是怎么样投入到您现在所做的这个行业和领域？
这个是一个比较长的问题，因为其实我刚才也跟那个 Mark 说过，就是我在进入公司之前，其实我是完全不知道ASML是一个什么样的公司的，甚至在我进入到ASML之后，我需要向我的爸爸妈妈解释这是一个什么样的公司，因为这个确实它是一个在荷兰威尔德霍芬一个非常小的一个村庄，但是它是默默无闻的在做一件事情做到极致的这样的一个公司。然后我跟ASML公司的一个起源呢，其实是在我瑞士做博后期间，当时我的一个博后的同事，他跟我介绍了这个公司，说，哎，我们现在做这个东西，如果说能够在这个ASML这个公司里面，也许我们能够把我们现在这个科学上的一些研究付诸于实践，做出一些真实的这个设备，那这可能是一个更有意义的一件事情。所以呢，当时我就跟我这个同事一起报名参加了当时ASML组织的一个叫做那个博士大师班的项目，就是 PhD Master Class。然后通过这个项目呢，就是结交了非常多的当年的这个全欧洲或者全世界范围内刚刚毕业的博士、博后，然后我们坐在一起呢，有2天、3天的时间，大家就在一起跟ASML的工程师、ASML的这个科学家一起在探讨公司可能会面对的未来的一些问题，那会真实的给我们出题，就是我印象非常深刻，就是说，如果说给你个晶圆，这个东西我们需要非常精准的 进行曝光，我需要去定位，你怎么样去做这个事情？我们完全都不知道，完全都不知道什么东西。然后通过半天的时间，我们小组6个人然后坐在一起，跟ASML的工程师一起分解这个题目，然后把这个难点把它分解开，然后每个人去做一个部分的工作，最终形成了一套整个系统的解决方案。然后也是因为这个契机，我是完全了解了ASML在做什么样的东西。然后也是通过这个活动呢，可能也是吸引到了我们当时 research department 的这个manager 的重视吧。然后说，哎，你这个东西也许真的能在公司里面用到。所以是通过这么一个契机，然后后续又联系，然后那个一步步的，当时非常艰难，我记得印象非常深刻，我进行了大概11轮的面试。进入到了ASML的研发部，是一个 long story 。
很好的故事。
Yeah, I just talk about how I enter ASML. Yeah, so I entered because of a program called the PhD Master Class. So I get to know what the company is really doing, and also I got some real questions from the engineer, and we make up a team to solve that question. And eventually we did a good job, and yeah, eventually I went to the company, went to ASML research department after 11 rounds of interviews.
Oh wow, 11?
Yeah, something like that.
And were you shocked by Dutch culture?
I think it's at the beginning, yes, because it's quite straightforward. It's very open, but after I realized this is really the fastest way to understand the real question, and then people can really sit together to only concentrate on the question itself.
Yeah, excellent example. Yeah. Yes.
Interesting. I've been to the country of Netherlands, but I've never been working with people from there. But I know that ASML is a global enterprise, so it does not only have Dutch employees, right? So it's kind of an international atmosphere. Well, Dr. Lin just mentioned that the company was in the middle of nowhere and nobody really knew about that company. And my question starts from here. ASML evolved from a small Dutch company to a global leader in lithography machine industry. And it was once small, obscure company that nobody had never heard of. Now its role, dramatically changed not only the industry, but also society. So what do you consider the most important point or the turning point along its development that shaped what it is today?
Well, I think you have to go back to the early days of ASML to capture its culture, because in the early days, ASML started out with nothing. So it was a spin-off of Philips, and it was only a technology on paper and one kind of feeble machine that nobody wanted to buy, and there were a lot of competitors. So back in the day, I'm talking about the 80s of the last century, there were like 10 companies building lithography machines. So the world didn't really need another ASML-like player. But because they had nothing, they had to outsource very crucial parts of their systems. And that was a different approach than most of their competitors, because companies like Nikon or Canon, they're conglomerates, and they usually use sources within their companies. And they also do other products like digital cameras or copiers, and which is kind of distracting. And ASML from day one was this one-trick pony, so it only built these kinds of machines that are capable of replicating semiconductors on a massive scale. And because it had to outsource so many things, it created an ecosystem that was able to add value to the machine. And even though ASML itself is like the architect overseeing the total design, these companies that, for example, Zeiss or Trumpf or VDL or ProDrive really add to the total IP. So there's a lot of shared IP within the network of ASML. And I think that sets it apart from a lot of other companies. There's an ecosystem thinking. And as we just discussed, because of its Dutch background, in general, Dutch people are quite blunt and direct and not always polite. And they're not really about hierarchy. They're not too fond of people one step up the ladder, which is actually a good thing if you design a very complex machine, because then you have to tackle the problems right away, and you can't rely on one person, a guy or a girl, on top of this pyramid, who has the total say and the total overview over this machine.
So-called chain of command.
It doesn't work with a complex machine like ASML built. So what ASML created was kind of parallel thinking across the company, but also across the ecosystem. There are a lot of parallel processes, and they really throw engineers at every problem. And being direct, well, it cuts the latency, because then, without getting personal, they really can shout at each other, because, well, you have to tackle these hard physical, chemical, you name them, mechatronical issues. And the only way to get there is to be blunt and direct, because then you save time, and then you have the opportunity to create a machine that's earlier than your competitor, that's working better than your competitor, and, for example, has better throughput or better alignment. So these are crucial elements. And if you look back at the strategy of ASML, well, it's quite easy to see there are, for example, the EUV license. It was around the turn of the century when ASML got this license to create the EUV machines. Of course, they had a lot of trouble getting to the point that EUV was economically viable, but it started with that license. So that was really a strategic move by Martin van der Brink, the former CTO. He was really sitting across the table in Washington, D.C., talking about this issue. And one of the other strategic things that ASML decided to do was take over Cymer, the light source research lab that eventually created, together with Trumpf and ASML, this device called the EUV lithography machine. And on the other end, you see that ASML was capable of really getting into the minds of their customers. And this good relationship with their customers made it possible. For example, the latest machines called High-NA. This is like the top-notch machine, costs $400 million. And the first customer signed the contract back in 2016 or 17, which was Intel. So there's a huge amount of trust among these customers to sign up with ASML. And I think that's because of these long-lasting relationships between people in the semiconductor industry. This is not a hello, goodbye kind of industry. This is really about people knowing each other, looking each other in the eye, meeting each other personally. And I think ASML really managed to play that game, and that's the reason why it's successful today.
Mm-hmm. Like DUV, deep, we need this deep trust. I'm going to give the same question to Dr. Lin. 林博，您觉得就是阿斯麦尔从默默无闻的一个小公司，对吧？怎么样走向巨头？您觉得这个发展的过程中，从您一个曾经在里面就职过的一个同事而言，您觉得是什么样一个转折点，或者说哪些正确的决定让他走向今天这个行业之巅？
我个人的一个体会，我觉得像如此大的一个这么成功的一个科技类的巨头，那肯定首先离不开的是科技上的一个创新。那刚才 Mark 也提到了，就是阿斯麦的这个员工对于科技的一个执着的态度，然后搭配着整个荷兰的这种开放和愿意对话的这种文化，我觉得这是他能够成功的一个基石。那当然呢，一个公司能够成功，并不仅仅在于它的一个这个技术的领先，那同时还有其他很多的因素。就我印象特别深刻，就是在读这个 Mark 这本书的时候呢，就是在阿斯麦刚成立的时候，他其实碰到了非常多的问题。那这些问题呢，往往不是技术的问题，那更多的问题呢，可能是这个像一开始资金的问题， 一开始它是飞利浦的一个spin off， 所以当时在飞利浦的时候，飞利浦并没有很大力的支持这样的一个项目。虽然这个项目可能我们外界来看是非常正确的这样的一个决定，但当时飞利浦呢，它已经成为了这个快消行业的一个行业巨头，它的别的业务线非常赚钱，所以它没有必要考虑这个事情。当然呢，在这个时候呢，那我觉得荷兰人呢，首先他这个锲而不舍的精神和愿意去开放对话的这个态度，就帮了非常大的忙。他很快的找到了当时我们荷兰的另一家也是半导体行业的，也算是一个巨头，就是 ASML 这个公司，它的创始人他非常愿意支持这个项目，那这就有了资金的一个支持。那同时呢，ASML这个开放沟通的这个态度呢，也非常快的吸引了荷兰的这个经济部的一个支持，那这就有了政策的支持，所以有了政策和资源，然后再同时呢又说服了非常多的愿意去参与这样的一个就是非常热血澎湃的一个项目的员工参与的话，那其实它就具备了一个那个公司能够去成功的各方面的一个因素了。所以我觉得在ASML这么发展的40年的这个过程中，我们可以看到的是有非常多的现在当今的这个技术公司可以去借鉴的东西。我觉得首先就是我们要专注这个技术本身，要有一个专于技术、精于技术、愿意开放的沟通技术的这样的一个包容的环境。除此之外呢，也需要我们包括政府、包括资金的一个大力的支持，同时呢，也需要有非常前瞻的这样的一个领导。刚才 Mark 也提到了，就是我们我前公司的这个当时的 CTO， 这个也是我们的一个精神图腾啊 ，Martin Van Brink。就是我非常有幸在研究部工作期间呢，也单独给他汇报过。我的一个感觉呢，就是他是愿意把一个技术跟你分拆到非常细的这样的一个领导，他其实不是一个领导，他愿意跟你探讨这个技术本身。我觉得这是非常难得的一个初创公司的一个心态。他已经这么成功的一个公司了，这样的一个非常大的 CTO 还愿意跟底层的技术人员去探讨一个技术的一个可能性，或者说是这个成功的这个可能。我觉得这是一个值得我们整个行业或者说整个这个全世界范围内的一个新的技术初创公司去值得借鉴的地方。
I think both gentlemen responded to the question with very similar answers. Cutting-edge technology, trust, corporate culture, and also support from both the government and public, talents, and senior management decision, like strategic management decision and vision. And also, you just mentioned Martin's. It's like one of the backbones of the company. And my next question would go to you, Mark. And from what you have can observe, we know that in 1995, ASML became a listed company on both Amsterdam and New York Stock Exchange. So how does ASML manage the tension, if there's any, between long-term R&D cycles, which always last about a decade or so, and short-term business pressure? I heard there was a downturn along ASML's development, but it has kept its R&D up. So from what you can observe, what ASML's senior management decision, like day-to-day decision making is like, and how do this mechanism work out?
Okay, well, I think that's an excellent example of one of the secret formulas of ASML, is that it's keeping its R&D spend on the right level, even during these downturns. And one could argue that that was the key element for ASML to gain market share when it was just a kind of a feeble startup. Because during these early days, back in the 80s, early 90s, sometimes half of the research budget from ASML was coming from the government in The Hague, so in the Netherlands, but also from Brussels, from the EU. And for ASML, it was really important to create these opportunities for themselves to come up with new innovative machines, so the next generation, right during the downturn, because then they were ready when the market started picking up, and that way they could beat their competitors. So, and you see that initial strategy is being stretched out even 40 years later, that even during a downturn like this, which, well, it takes quite long, ASML keeps its R&D spend up, because it knows that you need the R&D to out-innovate competitors, because they're still competitors to ASML. And the only way to keep ahead is out-innovate them by spending lots of money and talent and time on research. I think that's one of the secret elements of ASML.
I'm also going to ask Dr. Lin about senior management decision making. 林博，就是您当时也是一个团队的负责人，那么您有对下，也要对上。您觉得就 ASML 的这个决策有什么样的特点，跟其他的公司有什么样的不同？
我在公司的一个体会呢，就是这个决策首先是它一定是一个开诚布公的一个讨论结果。就 Mark 刚才也提到了，就是那个 ASML 其实是 hierarchy 特别没有的一个公司。就是其实我们在每一次做决策的时候呢，就是包括所有的这个最了解技术的这个底层的这个工程师，以及一个团队的负责人，以及整个 department manager， 我们都要这个坐在一起就是我们要非常直接的去问出，那你这个东西的一个优势在于哪？你的一个竞争力在于哪？有没有可能能够做得成？如果说要做这个东西的话，你要分拆时间你的这个成本，你需要的人力是多少，都是非常直接的问题我觉得ASML能够成功的一个大的前提，也就是我们能够把所有的问题摊开说没有什么东西是可以在别人面前隐瞒的。那这个工作方式就跟在美国的公司有非常大的一个区别。其实美国的工程师呢，更愿意去更专注的做他手头的一个事情，他不愿意去跟别人交流，他愿意把他手头的这样的一个技术做到非常精深。当然，他离开公司了之后呢，对于公司就是一个灾难。但是ASML不是这样的，就是每一个问题大家都非常清楚这个问题的瓶颈在于哪里。所以为什么ASML能够建立一个全球的一个供应链？这就是因为ASML愿意跟自己的供应商来同进退。很多的供应商其实在一开始的时候，他是没有能力提供ASML的零部件的。他需要也有自己的一个研发的一个投入，而且往往小的零部件的供应商没有这样的一个能力。那我的前公司怎么做的呢？ASML就是要跟这样的一个这样的公司同进退。甚至我们要投资这样的公司，同时呢要把自己最棒的这些个工程师也跟他们放在同样的这个课题里面。所以非常多的这个供应链，包括整个安盐湖湾地区耳熟能详的非常大的这个供应商，包括 VDL， 包括 ProDrive， 非常多的这个ASML的项目，很大程度上的工作是ASML公司自己完成的。因为他把最好的工程师放在了里面，所以很多人都在说ASML仅仅是一个组装公司，我觉得这不是一个公平的一个评价。其实ASML它就像 Mark 说的，它帮助整个光刻机行业重塑了这个产业链，它是真正的在拽着自己的供应商往前走甚至在解决不了问题的时候，它需要去买这个供应商，包括对于 Asml 的收购，对这个柏林玻璃的收购，这都是一个非常好的一个例子。所以我觉得有非常多的就是值得我们去借鉴的这样的一个ASML的成功的故事。那我觉得还是一个最重要的关键词，就是如何保持开放。我们怎么样把这个问题就是开诚布公的放在面前，这样大家都知道这个瓶颈在于哪，你的顾客也知道，如果说你的光刻机我知道你2年做不出来，但是我愿意给你2年这个时间。其实我们很多的顾客都愿意去等ASML的光刻机。Martin 每年都在 SPIE 的这个会议上说，我们的机子外再过2年就行了，说了10几年，但是顾客还是愿意去等，因为他知道确实这个东西很难，而且即使我现在逼你把这个东西交付给我了，我也赚不了钱。对，所以我觉得就是一个开放的一个这样的一个态度，怎么样能够让所有这个产业链愿意做你的朋友，这是一个非常重要的一个品质。
It's very interesting for me to be here on this spot because it's like I'm a journalist. I'm doing cross-checking. You're on the same page. You have been, mentioning about the open culture, the open communication, and not only among the senior management, but also among the staff, and also the ecosystem of its partners and suppliers. So that really what makes the success of the ASML piece.
If I can follow up on that, I think the best example we see today of ASML's focus on the long-term results is that the company was crazy enough to start with an impossible machine to create. So they started investing in EUV technology. I think it was in the early 2000s that they signed the contracts to do so. And they really underestimated the complexity of the machine themselves. So it was delayed for almost 10 years, and they were the laughing stock of the entire semiconductor industry. And I think that the total amount of R&D spent on that machine was like $15 billion back in the day. So they could have dropped out or dropped the ball. And I think there were times that Martin van der Brink was almost on the point, okay, we're not going to make it. But there was also an element of luck involved, and sometimes, because ASML is quite a chaotic company sometimes, but that also creates lots of creativity. And I think that's also an element you need solving complex problems like this. And that really helped, well, get EUV to the level where it is today.
Interesting. I'm gonna come back to the chaos part. And
Chaos theory.
Yeah. Dr. Lin is an engineer, so he just covered my next question. Is about ASML's engineer culture. I mean, it is widely praised, and from what you have elaborated on, I think that's exactly what I heard. And what do you think, Mark? The company ensure its engineering culture, to preserve this special culture amid fast expansion?
Well, sometimes I compare ASML with a chip design, because the company wants to keep the engineers close together, even on in a physical manner. So it wants the people to be able to, the talent to be able to negotiate and interact physically on the same floor in the same building, because that cuts out the latency. And that's the same thing you do when you design a chip. You keep the distances short so you don't lose any time. And that element of interaction is very important for ASML. So the company had a hard time during the pandemic because everybody was, well, confined to their homes and working and couldn't work at the office. And it also kind of, well, made them revalue the importance of being a collective. And I think there's a collective spirit at ASML. I don't work there, so I'm not talking for the company, but it's something I experienced writing about it, talking to people, and even talking to competitors or suppliers who were dissatisfied by the way they were approached by ASML or treated by ASML, but they also see the same thing, that there's a collective spirit in the company. And I think that focus is one of the elements that is spurred by the fact that ASML is a one-trick pony. So it mainly does these machines that can mass manufacture logic chips, memory chips. Of course, it does metrology, but it all is part of the same system. And it's not distracted by other machines or division that could lure away talent or money or time. And I think that's the secret. Yeah.
Interesting. To get things done, you have to focus. What about chaos? What happened? What chaotic moments that you have observed?
One of the... You remember 2021, of course, during the pandemic, there was lots of need for more semiconductors. So there really was an upcycle in the semiconductor industry because we all needed new laptops or monitors to work from our homes. And of course, the internet had to expand because everybody was using cloud services and doing Zoom and Teams sessions. So the world was well, craving for more semiconductors and also for more lithography machines, because it's the, well, often call it the oven in the bakery. So it's like the central tool in any chip fab. So the semiconductor manufacturers, mainly TSMC, was calling to ASML on the phone with Martin van der Brink, and they were shouting at each other, "Give me more semiconductor machines, and I need these lithography tools now, yesterday," because the president of the US, but also the German Bundeskanzler, they were very mad because their car manufacturers couldn't produce any chips. So there was a lot of pressure on ASML in 21. And during that day, during that year, they had a new logistics center right in the heart of their business. And so they had invented this great logistics center, all robotized, well, top notch. Well, you started, you know what's going to happen. Because when, when they flipped the switch and wanted to switch to the new logistics center, it just didn't work. It was silence because the software didn't work, the systems weren't integrated. So they had to call out all personnel, come on, please help us out, carry boxes, carry the wrapping paper, because the systems that weren't working. So even a high-tech company like ASML, well, these engineers really like the difficult problems, the really complex things, but they tend to forget, well, the less important things like logistic or HR. It's not so fascinating as doing these crazy things almost on a research level. So part of ASML's chaos is that sometimes they mess up. But the company is really good at error management. That's in the heart of their culture. So the whole lithography machine is kind of a collection of well, experience in error management, because it's well, a very complex machine to build, but also the semiconductors themselves are very complex to build. So you need to tweak it. You have to keep the yield up, and if you build really accurate structures or diminished structures, then the system gets too slow, so you have to balance it out against throughput and alignment. And during these processes, there are a lot of mistakes making, and ASML is really good at correcting these mistakes. And it does so in a, well, I call it an exclamation culture. So there's a lot of shouting and a lot of emphasis, and it looks chaotic, but in the end, most of the people know what they're doing. So the result is a machine that nobody else can produce.
Interesting. I mean, the chaos didn't come from inside, but come from outside. There was a shortage of chips. And so I'm going to ask you, Dr. Lin, I think you turned to China in the year of 2021, and I think that was during a period of chip shortage, right? And could you please elaborate on that experience? You know, what made you, think of coming back to China? 就是您是怎么样考虑在2021年的时候回国，然后来做一个职业生涯的一个转变？能不能请您分享一下？
这个其实是一个比较私人的一个原因，因为当时21年的时候，其实一方面是就是在公司的工作的环境有了变化，就是像 Martin Mark 说的，其实ASML的工程师更愿意面对面的跟大家坐在一起去讨论问题。然后21年的时候呢，其实就有了一个非常大的工作的一个模式的变化，因为很多的人就会开始用 Zoom， 用这个远程的办公的这个方式啊。当然这个也没有什么不好的啊。就我想说的是什么呢？就是其实ASML它是有一个咖啡文化的。就我本来进ASML之前是完全不喝咖啡的，但是因为进了ASML之后呢，我发现在咖啡机边上可以有非常多的灵感啊，因为非常多的同事，不管是哪个就是负责哪个业务线的同事，都会在那儿去喝咖啡，大家都会在那儿聊一会儿啊，然后在这个时候呢，会发生非常多的这个思维的碰撞，所以我大部分的专利其实都是在喝咖啡的时候完成的。从一开始我完全不喝咖啡，到最后离开公司的时候呢，其实我可能一天要喝5、6杯咖啡，不是因为我想喝咖啡，就是因为我就单纯的想跟同事们聊一聊啊，所以我觉得这个是当时能够让我非常开心的在公司工作的一个原因，它有一个非常开放的环境，而且我能够跟世界上最聪明的各行各业的工程师能够去当面的一个交流，那后面就有了一个变化。那更多的我为什么考虑回国呢？可能还是因为我的一个家庭的原因啊，因为我们这一代的这个中国人呢，其实都是独生子女，包括我爱人也是独生子女，所以在这个疫情期间呢，其实我们双方的父母年龄也都比较大。然后当时的情况也不是很理想，所以我们是希望能够离我们的家人近一些。所以当时也是跟我的领导谈的时候呢，我领导也比较惋惜，说还有没有可能啊，我们可以给你派到中国去一段时间，然后之后如果说过了一段再回来，我说还是算了，因为我可能长期还是希望跟我的家人能够待得近一些啊，所以可能是出于这么没有那么光鲜的一个理由啊，就最终回来了国内啊。
One of the reasons Dr. Lin mentions is about coffee, and I myself am addicted to coffee, like 2 or 3 per day.
Likewise.
Yes, I'm gonna buy you one after today's conversation. And I think it's very coffee is like a magic. It connects people, and I think there are people from different countries in ASML, and ASML suppliers are from across the world, and also competitors. So my next question, will delve into geopolitical related topics. Of course, I'm not gonna talk about some sensitive things, but I'm going to quote, one article that was published on the 25th March on The Economist, and it's titled "ASML's Boss Has a Warning for Europe." Mr. Christoph Futke, and he says that continent's champions could move elsewhere if they're not better protected. And Mr. Fouquet continues says that the pressure on ASML began to build in 2019 when the Dutch government and Americans barred the company from exporting its advanced EUV machines to China. Widening restrictions enforced by both the American and Dutch authorities subsequently extended to some older deep ultraviolet machines. And even under Mr. Biden, the rationale for restrictions was not always clear. And now President Trump's second term brings the threat of even tighter controls and the near guarantee of more uncertainty. So as a consequence, ASML's planning has been some more difficult. That's what the CEO said. And Martin, what do you think Trump's second term into the semiconductor industry for the whole world and to ASML, the company itself?
Well, I think it's early to fully analyze what the new administration of Trump will, what its impact will be on the export controls. I think the signs are that there will be even more strict, or at least the intention is there. But if you look back, you see that the first administration of Trump was the one that started the export controls today. And this started with the EUV machine, but of course, during the Biden administration, DUV was added, and the bar is getting lower and lower. Well, if you look at ASML, it depends for a large part of their revenue on Chinese customers. Last year, for example, was 40% of the revenue was coming from Chinese customers, and they really need their customers all over the globe to thrive, because it's healthy for the ecosystem. And I think ASML is very much aware that when it's not possible for Chinese customers to build or to use ASML's machines, they find themselves forced to switch to alternatives, or to even put more energy and more effort in development of a competitive lithography machine, because you need that tool to come to this next level. And one could argue that the export controls until this day haven't played out as they were intended, because you still see a lot of innovation in China. But lithography is a different ball game, and it's a really complex machine. And of course, there are elements, and there are competitors, local competitors like SMEE, and a company like Huawei is also diving into the technology. But it took ASML 40 years to get to this level. And the expectation is that ASML will keep R&D spend on this level, that they can out-innovate any competitors. But they do expect, an extra reason for China to spend more time and more effort in developing its own indigenous tools to create semiconductors. So now, regarding your question, when it comes to how this will play out, well, I don't have a crystal ball, so I'm watching this space just like you are. And for me, it's an evolving story. And you could say that ASML really benefited from the fact that the globalization took the company where we are today, and it also took innovation to the to the level where we are today, and which means that the tools we have in our pockets, or the tools we use to use ChatGPT or DeepSeek, they wouldn't have been possible if we didn't have that global system of innovation called the semiconductor industry, which led ASML to provide the tools for every customer.
Very interesting. I mean, ASML's example is a fantastic one about collaborative work, and also is about collaboration across the whole world. And I'm going to turn to Dr. Lin. I'm going to talk about Asml. 林博，您看能不能帮我们简单介绍一下？因为我也是个小白啊，但是我听说早年的时候，ASML是收购了一个美国的公司叫 Asml， 而且收购案对于 ASML 的这个发展来说是个非常重要的一个转折点。那这是不是一个双赢的一个合作，还是说可能对于美国来说它可能是一种损失？那比如放到今天的话，您觉得美国会不会把 Asml 这样一个非常重要的半导体行业的公司卖给他们未来的这个潜在的合作伙伴，行业的巨头ASML？
我觉得这是一个挺好的问题，然后这个问题的答案其实也能在这个 Mark 的书中找到。其实当时那个ASML主要收购 Asml 的一个原因呢，就是因为当时我们的 CTO Martin Van Brink 真的是不能再等了，因为其实对于 Asml 来说，他去做一个 EUV 的这个光源的这个决心其实没有那么强，因为他的其他的业务线也是非常赚钱的，包括他的这个 DUV 的这个光源。DUV 其实不光是给ASML供货，包括给这个日本的这个竞争厂商，包括佳能啊、尼康，其实也都在供货的，所以它这个每年的这个就是收入其实是非常稳定的。那为什么他愿意去做这个事情呢？其实他本身是没有非常大的一个决心和动力去做，所以呢，也是那个我觉得可能也是公司看到了这样的一个情况，所以想要扭转这个局面，那就采取了收购ASML收购这个 Asml 的一个方式来进行同这个共同的一个研发。那其实，在ASML的这个发展的过程中呢，这个类似的这个收购案是非常多的，包括对于这个蔡司的这个半导体事务部也进行了这个25%的这个股份的一个收购，然后对于这个在德国的这个柏林玻璃，它也是进行了一个收购。那在这个过程中呢，其实我们可以看到，就是ASML它其实不是一个愿意，怎么说呢？它并不是一个愿意去这个促进竞争的这样的一个公司，它更多的是一个愿意去扶植能够把技术做到最精尖的这样的供应商来为它所用的这样的一个公司。所以在这个考虑中呢，我觉得ASML来收购 Asml 是它一定要做的一步。那可能不收购 Asml， 它也要收购别的公司。那现在回到你的问题呢，就是美国会不会这个后悔？我觉得他没有必要后悔，因为其实美国在这个在现在的这个国际环境里面，就是因为ASML做出了极紫白的光刻机，其实它也得到了非常多的好处啊，比如说现在最好的芯片都留在了美国。最强的这个 AI 的这个大模型，那个都是由最好的这样的算力的芯片来支撑的。那所有的这些能够实现，都是由于 EUV 的这个光刻机有了一个非常长足的一个进步，能够把它做出来。那如果说当时没有 ASML 对于 Asml 完成收购的话，那可能这个进程会继续去推迟。我们现在可能都用不到7纳米的手机，因为我们知道2019年的时候，第一次应用 EUV 的光刻机做的是7纳米的手机。那如果没有 EUV 或者它推迟，那就意味着我们现在甚至连 AI 的这个大模型都没有办法去部署。那当然，我觉得这是没有办法去估计的一个对全世界的一个损失。所以，如果说你说美国后悔，我觉得可能更应该高兴。
So I'm going to pass on question. We know that semiconductor lithography was invented in the U.S. military lab, and for a long time, up through the 1980s, the key lithography firms were American. And later there were other competitors like Nikon, Canon, and also Asml from America. And the question I asked Dr. Lin was that will the U.S. Agree to sell Asml to Asml today? It was given today. I mean, did they regret the decision of selling Asml to ASML?
Excellent question. I think today will definitely be other situation because we have a different geopolitical situation. But in the end, look, EUV was started in research labs all over the world, also in the Netherlands, also in Japan, and also in the US. But the US invested a lot in these initial attempts to conquer this technology, but it was quite hard. And the US companies, no, they couldn't manage. There was one EUV license held by a company called SVG, and this company was providing lithography machines to Intel, the semiconductor manufacturer from the US. And SVG was not capable of getting this technology working. So ASML bought SVG, acquired an EUV license, and that was a kind of the start for the fact that there was only one company that had all the EUV licenses, which was ASML. This was during the 2000s, early 2000s. So there was a lot of discussion, a lot of debate on a political level, even during that time. Now the same thing happened when Cymer was acquired. It took a while for ASML to decide whether or not they should buy one of their suppliers, because Cymer was basically just a supplier of lasers to the entire energy industry. But Martin van der Brink, the CTO, he really noticed that the Americans weren't capable of getting EUV. Well, they got it working in a lab situation, but ASML's speciality is industrializing stuff. And the things that were produced in Cymer weren't capable of industrializing the EUV technology. So you could have it running in a lab, but it wouldn't work in a semiconductor fab where it has to produce wafers hour after hour, 24/7 hours a day, every day of the year. So that's a different mindset. And for this to happen, ASML had to acquire Cymer. And there was no alternative for for example, players like Intel. They kind of co-invested in ASML, so ASML would have more opportunity, more capex to keep R&D up because it was rising because of the huge challenges in EUV. So Intel was one of the co-investors that gave ASML the opportunity to buy Cymer. So would it play out differently this time? Definitely. But would the industry have gotten any further when it comes to innovation on the EUV level? I doubt it that the EUS would be capable of doing it itself. I think in my book I conclude that they dropped the ball on lithography because they didn't think it was important enough. And if you look at the financial stack of the semiconductor industry, one could argue that they were right, because most of the profit is not into the semiconductor manufacturing or the tool makers, but in the chip makers, NVIDIA or Apple, or the software makers. Excellent companies like Google or Microsoft, they make a lot of money based on that stack. And you see that often in history, for example, also in telecoms, where the US decided, well, this is not our ball game, we leave it up to others, with consequences.
Yes, I mean the US has the Magic 7, but they don't have ASML. And my question is about the publicity, I mean, the possibility to replicate the supply chain. I mean, you know that China is ramping up its chip manufacturing, and also the US and other counterparts across the world. And in September 2023, the US Department of Commerce said that the US is seeking to attract more chip production facilities with the goal of establishing at least 2 cutting-edge semiconductor manufacturing clusters by 2030. And speaking of today, and there is a big Semicon China show ongoing here in Shanghai, a lot of buzz and a lot of exhibitors. And do you think it's possible for other countries or other companies to follow its suit, or say to create another ASML to replicate its supply chains?
Well, you could say that even though if you would have the blueprint of this lithography machine, which isn't there, there's no one drawing saying, oh, how to build a lithography machine like a Lego box. But if you had the ingredients, then there's still a number of challenges that are very hard to solve. And I'm not saying it can be done. Of course it can be done, but it will take a lot of time to get to this level, because you have to make sure that all the parts play together. And ASML's machine is like a marriage of well, hundreds of thousands of parts and modules, tens of modules, and each have to, it's like an orchestra playing together. And you need software for all these crazy hardware to keep it together. And inside the machine there's like enormous forces that have to be kept together. And the smaller the chips get, or the smaller the transistors on a chip will get, so the latest generation has 200 billion transistors or more on the surface of your fingernail. The bigger the machine gets, so the latest generation of ASML is like 40 meters wide. It's huge. So that's very hard to replicate. But I think what's even harder to replicate is the kind of spirit and culture you need for engineers to cooperate in the way that ASML, well, has grown to be. I don't think they intended to be a company like this, but it was a kind of, well, as I described, a cowboy culture, a chaotic culture, but also a very challenging culture. And they kept it together. And I think even if you're in the Netherlands and you set 1 foot over the border, you step 1 foot in Germany, then the culture is completely different. If you ever worked with Zeiss, that's one of the German suppliers, it's a different attitude. Things have changed, of course, and ASML is not a Dutch company anymore. It has 144 nationalities, so it's really a global company. But the core of the company is still this blunt, direct, challenging attitude where you're supposed to challenge your bosses as well. And I think that's very hard to replicate, for example, in other cultures.
Interesting. Earlier in our conversation, you mentioned like ASML is like an architect, orchestra. It's like a conductor, conducting all parts of the magic, like capital, talent. And speaking of talent, I'm going to ask this question, Dr. Lin. 您在荷兰的时候，在阿斯麦尔，您觉得阿斯麦尔这个公司它人才培养有没有什么样的特点？因为我们知道，对吧？不只是打工人，对吧？你就是给公司做贡献，但是可能也是一种双向的赋能，就是企业也在帮助员工成长。您觉得在这个层面的话，有没有一些特殊的感受，一些特别的观察？
我觉得就是帮助员工成长，可能是我觉得可能不光是阿斯麦尔，可能是很多欧洲公司都愿意做的一个事情。当然我只在阿斯麦工作过，那我可能就只能谈谈我的那个一个体会。就我进入公司的时候呢，我发现其实公司是有非常多的这个员工培养计划的，就是你有一个网站，你可以去选你要去学的东西，有非常多的这个 soft skill。就是你可以去学非常多的软技能，就比如说怎么样能够去这个 influence without power，然后那个怎么样去 manage time，类似这种课程你都可以在这上面选到。然后一般上这种课的时候，我的一个体会，作为这个在国内那个这个生活过的人，我的一个体会就是，如果说上这样的课程，可能你需要去请假，你需要去用自己的时间去做，但是在公司里面，其实这都是算在你的工作时长里面的。所以其实我觉得，类似这种这个帮助员工成长来说的话，可能不光ASML，包括它的这个隔壁的几家公司，包括恩智浦啊，包括飞利浦都做得非常好啊，就是起码我看到的周围的朋友们都是这样的一个情况。那可能我想就是回复一下您之前那个问题，因为你之前问 Mark 就是就说这个重塑产业链这个可能性啊，我是愿意从这个技术人员的角度去分析一下这个事情。其实我觉得对于技术人员来说，如果说技术人员有选择的话，他其实不愿意再做一样的事情。如果说我以前做过一个事情的话，你现在让我重新再做这个事情，我不愿意去做。所以其实是对于做技术的人来说，这是一个非常浪费时间、浪费精力的一个事情。但是问题就是在于你有没有选择。
It's interesting. Dr. Lin answered my question about the possibility of replicating the supply chain in a very wise way. He said, top engineers don't like copying.
Oh, that's
so smart.
Yeah. That's a nice way. Yeah, it's not a challenge to copy.
It's just waste of time.
Yeah.
Some people already did that. There's no point to do the same thing. If you want to do, in a different way.
Yeah. That
yeah.
makes sense.
Yeah, so let's continue with this topic of talents, attracting of talents and keeping talents. And I heard that there is a plan called, or initiative, or a plan called Beethoven by ASML. And could you please elaborate on that plan if you know anything about it?
Well, I wrote about the project Beethoven, as it is called, named after the famous composer, but it had nothing to do with the project itself. They just liked the name. And so it was the code name for a state subsidy project, not for ASML itself, but for the public transport, for the infrastructure, for schools to create opportunities for technology students to not only to get to work for ASML, but also well, apply for a job at one of their suppliers, because ASML's supply chain is very spread out in the region, not only in the Netherlands, but also in Belgium and Germany, even France. So it's very important that there's enough talent to keep this company on a level that they still can compete with new technologies and new challenges. And the Netherlands is just a small country, so we don't have enough engineers and brilliant minds. And if you look, for example, the total number of employees at ASML is like over 40,000. I think about 43,000 now. And I think nationality number 4 is Chinese. So there's a lot of talent also from abroad working not only in Eindhoven or in Veldhoven or in Meerhoven. That's where he used to live. But also in other places. So, for example, in Silicon Valley in San Jose, there's a ASML department which has well, mainly a Chinese background, and brilliant minds are working there on the metrology systems. And I think it's me being Dutch, it's inspiring to see that we have a multinational player that's so spread out all over the world, where there's so many young people well, eager to work at a company like that. Of course, it's paying well.
Yes, of course. I've just mentioned about Silicon Valley, and I think there are a lot of the hotspots with technology development, and China is another hotspot, and AI is a hot topic. Speaking of Semicon China, and the capitalization on AI momentum is one of the hottest topic on this exhibition. So I'm going to ask you, so what will this factor of AI play out in the development of ASML? And what about the role of AI in shaping Europe's role in the landscape of technological rivalry, if we call it rivalry?
Let's turn to the DeepSeek moment. Was it last January? Who of you is using DeepSeek? Show of hands, or everybody, of course, yeah. Which was a great example of democratizing technology, because the AI models used to be mainly US-based, because there was a lot of compute available to develop these models like OpenAIs or Metas. And now you see an alternative technology that's open source, so everybody can figure out what they want to do with it. And so there was a large market response because everybody thought, oh, so we don't need any advanced semiconductors anymore to create new AI. Well, forget it. When you democratize a technology like that, that means people are going to use it more, and it's going to be easier and more accessible, and it's going to be working even in edge devices like your laptops or mobile phones. So there's a huge opportunity for ASML to provide more semiconductor lithography machines to the entire world. And of course, AI is also in the models that ASML develops itself to digest all the metrology data, because these are systems that use huge amounts of data to get the compute to, to do error management and to see how they can tweak the wafers and the machine so they can produce the best amount of yield. So you see that ASML is also digesting that technology to improve its own product. Coming to your question about Europe, of course, Europe is very much behind when it comes to the availability of its own brand of hyperscaling. So the market is really dominated by companies from the US. And I think in the Netherlands there's a lot of discussion about should we really be as depending on these huge tech firms as we are now. So there's a crave for an alternative, and but it takes time to build an alternative for such huge companies that provide excellent products. But like with semiconductors, you don't want to be too dependent on one player, especially during these geopolitical turmoil.
Mm-hmm. Speaking of geopolitical turmoil, we know that semiconductor industry is capital intensive and talent intensive, but still there are not external factors sometimes like you cannot control. Therefore, greatness sometimes cannot be planned. And I don't know if you have been in touch with the senior management of ASML up till now, and have they ever talked about their future planning? We don't have to talk about 10 years, maybe future 3 to 5 years in the face of these political tensions. What are on their minds? What are they planning on?
Well, I'm always careful talking about the future because, well,
we're not futurists.
No, okay, I'm not a futurist. I don't have a crystal ball. There's no warranty, no guarantee that things are going to happen. So I'm not going to get into that. What you see in general is that, for example, I was here in China last fall, and I spoke to a lot of Dutch companies, tech companies here in the Shanghai and Suzhou area, and they're like reassessing their strategy. And I think mainly they're choosing not to leave China, but to build a supply chain for China, and to build a supply chain for the rest of Asia, maybe for the US. So they're like spreading their risks because, and this is not what ASML is doing, but this is just what other technology companies are doing. And that's the only way to be somehow prepared on things that might happen in the future. But nobody knows the answer to that question, actually.
Yes. I think what ASML has created together is a kind of a miracle, you know, that is ultimately built on a delicate chain of trust and also featuring deep specialization and collaboration. And could you please give us 1 or 2 sentences to summarize your book? I know it's a stupid question because you're author of the book, but for those who haven't read your book, and could you please give us 1 or 2 sentences, either to summarize it or to, you know, to give a gist of what interests yourself as author the most?
Okay, so for me, what inspired to write the book is, well, you can have a look at it.
Thank you so much.
The fact that we trust in our daily lives on all these zeros and ones. We look at our computers, our computer screens, and we think, okay, it's just bits and bytes, completely digital. But if you delve into the technology, really behind the foundational technology, it's really analog. It's about people. It's about physics, and it's about stories and adventure and challenges. And so the stuff we usually take for granted, just staring at our phones, comes from a time where these things were actually invented. And to me, that's the miracle.
Yes, fantastic. And could you please give us 1 to 2 sentences, you know, to the young students who are keen to get in, you know, the industry of lithography, of chips?
Okay, so just know what you wish for, because it's I think it's a daunting industry, but it's also an industry that's very inspirational. So, for example, I talked to people working in Silicon Valley, like the holy grail of innovation, and they chose to work for ASML because they wanted to dive into the really interesting problem. They didn't want to invent Instagram filters. They could even make more money at another company, but they wanted to build real stuff, stuff that can change the world. And I think that's an inspiring thought if you want to study a subject like that.
Yes, yes. And Dr. Lin, what about you? 您可不可以对我们想要学习光刻机、了解光刻机，或者说甚至进入芯片行业去参与研究光刻机的年轻读者们、观众们，有没有什么想说的？
我觉得这个 Mark 这本书，如果说用一句话来概括的话，那就是阿斯麦的这个历程，它其实就是一个 making impossible things possible 的一个非常完美的这样的一个历程。其实对于年轻的包括我对我的学生也说，我们作为一个年轻的这个工程师也好，或者说科学家也好，一定要坚定自己的一个梦想啊。这个有可能你这个梦想目前来看是不现实的，但是也许你因为有了这个梦想，在你的前进过程中可以找到志同道合的朋友，跟你一起把这个事情解决，那就是阿斯麦做的事情。
Thank you for your final thought, Dr. Lin. So, last but not the least, Mark, what's your next book about? What you're gonna write about in future years?
Ooh, that's a challenge. A very difficult question to answer. I'm not sure. I think there's a part 2 in this topic. So I'll have to dive in that right now, I guess.
Okay, yeah. Well, it has been a very rich talk today. Thank you, Mark. Thank you, Dr. Lin, for your time. And I would like to urge all of you to go and pre-order the book and dive into the details. Thank you for your time. Ladies and gentlemen, please stay in touch and stay tuned. Bye-bye.